Let's take this example to understand correlation coefficient computation. We have to calculate correlation coefficient from the following data, which gives marks obtained by 10 students in maths and statistics. So this marks in subject maths is your variable 1, whereas the marks in subject statistics is your variable 2, and it is represented by x and y. So now we have to measure what is the degree of relationship between these two variables. That is, basically we have to calculate the correlation coefficient. So how do we calculate correlation coefficient? Correlation coefficient is represented by the symbol R, and it is Pxy divided by standard deviation of x and standard deviation of y. So to calculate this covariance of x, y, we need summation of x minus x bar and y minus y bar divided by n. And for calculating the standard deviation of x, what we need is summation of x minus x bar the whole square by n and square root applied on that. Similarly, we have to do for y also. That is going to be summation of y minus y bar the whole square by n. So it means we have to find out what is x bar, we have to find out what is y bar. And what is x bar, what is y bar? X bar is nothing but summation of x by n, y bar is summation of y divided by n. So first let's find what is summation of x. That is, we have to total here. If we total this, we will get summation of x. So what is summation of x? If you total all this, you would get 590. So that is summation of x, and we'll do the totaling of y. That is summation of y is equal to 610. So now we have summation of x and summation of y. So we can find x bar and y bar. And how many items we have in both the variables? We have 10 and 10, right? So x bar is going to be summation of x, which is 590 divided by 10, and it is 59. That is x bar. And we have y bar is equal to 610 divided by 10. So y bar is equal to 61. What is our next step? We have to find what is x minus x bar. That is 46 minus 59, which is minus 13. 54 minus 59, and it is minus 5. 64 minus 59 is 5. In this way, we have to compute for each and every case, and it is like this. It goes to 3, 1, then 4, 5, minus 1, minus 11, and 12. So this is our x minus x bar. Then we have to find out what is y minus y bar. But before that, we'll also take the square of this. That is x minus x bar square. So 13 square minus 13 square will become positive 169. Minus 5 square will become positive 25. 5 into 5 is 25. 3 into 3 is 9. 1, 16, 25, 1, 121, and 144. And if you total this, you are going to get summation of x minus x bar square, and it is 536. The same way, let's do for y minus y bar. We know y is 43, 57 goes up to 72, minus y bar is 61. So 43 minus 61 is minus 18. 57 minus 61 is minus 4. Then we have 66 minus 61 is 5, and it goes like this. It becomes 7, then followed by 2, 6, 9, minus 5, minus 13 and positive 11. The next computation is we have to find out what is y minus y bar square. That is, we have to square this. So minus 18 into 18 will give you 324. Minus 4 square is going to give us 16. 5 square is 25, 7 square 49, 2 square 4, 6 square 36, 9 square 81, 5 square 25, 13 square 169 and 11 square 121. And if we are going to total this, it is going to be summation of y minus y bar square, and it is 850. So now we have most of the information, but for finding covariance we need the product of x minus x bar and y minus y bar. That is, here we have x minus x bar and y minus y bar. So we need the product of this. So let me just change the color. So we have to find the product of x minus x bar and y minus y bar. So it is minus 13 into minus 18, so it is 234. Minus 5 into minus 4 is plus 20. 5 into 5, 25, and it goes like this: 21, 2, 24, 45, 5, 143 and 132. So now if you sum this, you would get this value, that is summation of x minus x bar and y minus y bar, and it is 651. So we have most of the information. Now we'll try to make use of these information. So to start with, our correlation coefficient R is covariance of x y divided by standard deviation of x multiplied by standard deviation of y, and covariance of x y is summation of x minus x bar and y minus y bar. Summation of x minus x bar, y minus y bar divided by n whole divided by standard deviation of x into standard deviation of y. So it is standard deviation of x, and how do you find the standard deviation of x? It is summation of x minus x bar square by n into summation of y minus y bar square by n. So what is the summation of x minus x bar into y minus y bar? We have that is 651. So 651 divided by n. What is n here? N is 10 divided by square root of summation x minus x bar. We have that, which is 536. 536 divided by 10 into square root of summation y minus y bar square, which is 850. 850 divided by 10. So this is going to be 651 by 10, that is 65.10 divided by 53.6 into 85. So this is going to give us the value as 0.96. So here what we get is R is equal to 0.96. So this is the correlation coefficient, and this R of 0.96 is very close to 1, very close to 1. And when correlation coefficient is 1, there is a perfect positive correlation, and this R is equal to 0.96 is very close to 1. So what does that communicate? There is a close relationship between the marks obtained by the students in these two subjects, that is mathematics and statistics. It means if a student is going to score a high mark in maths, he is going to score high marks in statistics also. Just have a look at here. but it is not perfectly matching, but there is a high degree of relationship. Look at here, when he is scoring 64 in max, he is scoring 70 in stat. When he is scoring 60 in max, he is scoring 63 in stat. And when he scores lesser, I mean when he scores 46 in math, he scores 43 in stats. So there is a high degree of positive correlation between these two subjects.